Here we go, brand new section, section 4. It's titled Property of Exponents Review. If they're going to take about, 3 weeks, a month of Algebra 2, boom, put it in one lesson. So I hope you're ready. All right, so we're going to start out with the basics here. And we have, when the bases are the same and you're multiplying, you add the exponents. When you raise a power to a power, you multiply. When you divide, technically, you subtract the bottom one from the top. Now, the way I like to explain it is this way, because it makes it just a little easier. Think of this as upstairs and think of this as downstairs, and ask yourself the question, if this represents temperature and that represents temperature, where is it warmer, upstairs or downstairs? You would say upstairs. By how many degrees? 5. Now watch this. How about this one? Well, if I followed this rule, I would go x to the 2 minus 7, and then I would get x to the minus 5. Now, I know this lesson over here says negative exponents, so I'm going to get back to this in a little bit. But remember the temperature lesson. But I'm going to go ahead and jump start a little bit. Where is it warmer? Well, it's warmer downstairs. By how many degrees? 5. So somehow this equals this, but we're going to talk about it over here. Okay? So, real quick, mathematical no-no. Now, from this rule, a lot of you have had problems like this, where you go, oh, power to power, 4, power to power, 6. And that's no problem. Why? Because this is connected by multiplication. But then when students see this, they think of this rule, so they distribute, like there's an invisible one here and there's an invisible one here, so they distribute that power through and they think, okay, that's 3 squared plus 2 squared. Well, that's 9 plus 4, which is 13. But wait a minute, PEMDAS, what's 3 plus 2? 5. What's 5 squared? 25. This is correct. This is a no-no every single time. If there's plus or minus in here, you may not distribute that through. Keep that in mind. Now this guy, 3 cubed is 27, 3 squared is 9, 3 to the first is 3. I don't think you guys have any problem with that. Now we're going to develop a little pattern. What do you got to do mathematically to get from here to here? You divide by 3. What do you do to get from here to here? You divide by 3. Now, math doesn't defy itself, so we're going to follow this pattern and let things kind of fall into place. Watch this. So what's 3 divided by 3? 1. You just were reintroduced to a rule. Anything to the 0 power is 1. Keep that in mind. What about this one? Well, for this one, you're just going to divide this by 3, and you're going to get 1 over 3. Now watch this to the first. Now I'm going to make this a lot harder than it needs to be, but it's so that I can establish a rule. So be patient with me, please. So from here to here, what am I going to do? Well, the same thing I did here, divide by 3, divide by 3. So I'm going to take this math problem over to the side, 1 over 3 to the first, watch this, divided by 3. Isn't that the same thing as this? Times, and then this would be 1 over 3 to the first. Now watch this. I know a lot of you are already jumping ahead and you're going, oh, it's 1/9. I don't want to take that step. When the bases are the same and you're multiplying, what do you do with the exponents? You add them. So I get 1 over 3 squared. You see that's 1 over 3 squared. Now what I'm going to try to prove to you is this negative exponent simply means put everything else where it ain't. So put it in the denominator. So what's this going to be? Well, that's going to be 1 over 3 cubed, which takes us back to here. Isn't this just the same thing as x to the negative 5th power over 1? Which means that negative exponent is telling us put all of this down. And that's why it ends up equaling this. All right, now for the last part of this lesson, square roots. You might be going, oh, I've seen these a million times. Well, there's a little curveball coming at you, so watch this. Square root of 49, I think you all know it's 7. Technically, it's plus or minus 7, but they just want what's called the principal root right now, which is the positive part of the answer. What about this guy? Well, you already know that 7 squared is 49, so we already know that the answer to this is the same as this, so it has to equal 7, but wait. there's an invisible number right in that little crease that's called the index. And now watch this very carefully. I'm going to experiment with this. I'm going to take this over to the side. I'm going to take this guy, build a fraction, put that in the top, put the index in the bottom. 2 divided by 2 is 1, and I get 7. Now, yeah, you might be saying, well, that's a hard way to do that problem. Yeah, I agree with you. But that, I'm teaching you what to do on these that aren't quite as easy. So now watch this. If I took this problem and I said, okay, I want to go 8 squared first. And then I get the cubic root of 8 squared, which is 64. And then I sat there for a while and I'm like, that's not the square root of 64, but that's the cubic root of 64. So what number times itself? 3 times is 64. The answer would be 4. Now watch this. What if I took the cubic root of 8 first? Well, that would turn into, what's the cubic root of 8? 2. And now I go 2 squared. What's that? 4. So on these 2 examples, I'm showing you it doesn't matter what order you do it in. What about this? Well, look, guys, I'm going to take this example back to this example. Remember the 2 down here is what's in the top. The 2 here in the crease is what's in the bottom. So this is the same thing as, see, that's in the crease, the cubic root of 8 squared. Now, what I would beg you to do is, after you've done 10,000 of these, you're not going to literally write it out. Your brain is going to go, oh, that's the cubic root of 8. And I would beg that you do that first, because the numbers are getting smaller rather than larger. Makes your life a little easier, especially mentally. What's the cubic root of 8? 2. What's 2 squared? 4. So you can jump right over this. What about this one? Well, that's a negative exponent. So what I'm going to do is I'm going to say, okay, well, that's the same thing as 1 over 8 to the 2/3. See, we've obeyed the negative exponent. Remember that rule over here? And now we're going to go cubic root of 8 is 2. 2 squared is 4. So I get 1/4. There's a lot more of these coming, but that's a great warm-up for all these little sample problems coming.